September 15th, 1940, 18,000 feet above the Thames Estuary, Flight Lieutenant James Nicholson's Spitfire Mark II screamed through a climbing turn, Rolls-Royce Merlin engine howling at 2,850 RPM. The Hurricane squadrons below were engaging the main bomber formation. Nicholson's job was the Messerschmitt 109's diving from the sun. His fighter responded instantly to every control input, rolling, climbing, tracking the German fighter through gunsight. The convergence was perfect. 8 Browning machine guns erupted. The Messerschmitt trailing smoke fell away toward the channel. Nicholson landed at Biggin Hill 40 minutes later. Ground crew swarmed his aircraft immediately, not for battle damage assessment, for bearing inspection. Flight Sergeant Williams pulled the cowling panels, exposing the Merlin's accessory section. He checked the supercharger drive bearing first, running his finger along the housing, feeling for heat, listening for roughness. Then the reduction gear bearings, then the coolant pump. Every bearing got inspected after every sortie now. They'd lost 3 Spitfires in August, not to German guns, but to seized bearings, engines that suddenly locked at altitude, pilots forced to glide home or bail out over enemy territory. Williams found nothing wrong with Nicholson's aircraft. Every bearing smooth, cool, functioning perfectly. But he knew what the engineering officers knew, what Air Chief Marshal Dowding knew, what terrified Lord Beaverbrook at the Ministry of Aircraft Production. Each Spitfire required 73 precision ball bearings. Hurricanes needed 65. Lancaster bombers over 200. Every bearing had to function flawlessly under extreme loads, high temperatures, and constant vibration. A single bearing failure meant a lost aircraft, probably a dead pilot. Britain was producing Spitfires faster than Germany could shoot them down. Fighter Command had won that race, but Britain had lost a different race entirely, one that started decades earlier and thousands of miles away. Before the war, Britain imported 90% of its ball bearings. Most came from Sweden, from a company called SKF, Svenska Kullergerfabriken, founded 1907, which by 1939 controlled 60% of global bearing production. German manufacturers Feig and Fischer supplied the rest. British bearing manufacturers existed, but remained minor players. Ransom and Marles, British Timken operating under license, Hoffmann Manufacturing in Chelmsford, which produced precision gauges and measuring instruments, not bearings at scale. The dependency seemed reasonable in 1935. Sweden was neutral. Trade routes were open. SKF's bearings were excellent, their prices competitive. Why invest millions building domestic capacity when imports worked perfectly? The Air Ministry and aircraft manufacturers made rational peacetime decisions that became catastrophic when peace ended. On September 3, 1939, Britain declared war on Germany. Within weeks, German U-boats prowled the North Sea and Baltic approaches. Swedish merchant ships carrying bearings to Britain faced torpedo attack. Insurance rates tripled. Shipping companies refused routes. By December 1939, bearing imports had dropped 40%. By April 1940, after Germany invaded Norway and Denmark, sealing off the Baltic, imports fell 70%. The mathematics were brutal. Britain needed 50 million bearings annually for war production. The aircraft industry alone required 8 million bearings per year. Pre-war imports had provided 45 million annually. Domestic production capacity in September 1939 stood at 12 million annually. The gap, 33 million bearings, represented the difference between fighting and surrendering. Fighter Command could see Luftwaffe formations on radar. Pilots could intercept them. Ground crews could rearm and refuel aircraft between sorties. But none of it mattered if bearings failed. The Merlin engine's supercharger bearing ran at 15,000 RPM. The reduction gear bearings handled 3,000 horsepower, transmitted through components smaller than a fist. These weren't components that could fail gracefully. They failed catastrophically, instantly, fatally. Britain could build Spitfires faster than pilots could fly them, but without bearings, those Spitfires would sit on the ground while Messerschmitts owned the sky. You cannot simply make ball bearings. The precision required defies casual manufacturing. Each bearing consists of an inner race, an outer race, and perfectly spherical balls rolling between them. The races must be ground to tolerances measured in microns, 1 micron being 1/1,000,000th of a meter. Surface finish matters enormously. Roughness creates friction points that generate heat, accelerate wear, and cause failure. Aircraft bearings demanded even tighter specifications than automotive or industrial bearings because consequences were absolute. No second chances at 25,000 feet. The steel itself presented problems. Bearing steel requires precise carbon content, approximately 1%, combined with chromium for hardness and corrosion resistance. The steel must be heat-treated to specific temperatures, held for exact durations, then quenched and tempered to achieve Rockwell hardness between 60 and 64 on the C scale. British steel mills in 1939 could produce bearing-quality steel, but consistency varied batch to batch. Swedish and German manufacturers had perfected metallurgy over decades. The grinding machines represented another barrier. Producing spherical balls accurate to microns required specialized equipment Britain didn't possess in quantity. The machines themselves needed precision bearings to function, creating a circular dependency. You needed bearings to make the machines that made bearings. Rolls-Royce, which built the Merlin engine, understood these constraints intimately. Their engineers specified bearing, tolerances down to fractions of 1,000th of an inch. The engine's accessory drive section alone used 14 bearings. The supercharger, which forced air into cylinders at higher pressure, enabling the Merlin to produce 1,200 horsepower, depended on a single bearing that experienced temperatures exceeding 200 degrees Celsius while spinning at 15,000 revolutions per minute under enormous thrust loads. When that bearing failed, the supercharger seized. Engine power dropped 70% instantly. Most pilots couldn't maintain altitude. Some made emergency landings. Others didn't make it home. By August 1940, bearing failures were killing British pilots faster than some Luftwaffe squadrons. Hoffmann Precision Engineering occupied a modest factory in Chelmsford, Essex, 30 miles northeast of London. Founded in 1898 by Heinrich Hoffmann, a German precision engineer who had immigrated to Britain in 1891, the company manufactured gauge blocks, measuring instruments and jigs for British industry. By 1938, Hoffmann employed 200 workers and had developed grinding machines accurate to 1/10,000th of an inch, precision that matched Swedish SKF. Hoffmann's managing director in 1938 was Thomas Barlow, an engineer who had worked briefly in Sweden and understood bearing manufacturing intimately. Barlow recognized Britain's strategic vulnerability. He began secret experiments in bearing production, developing tooling and training workers without government contracts or official encouragement. When war came in September 1939, Hoffmann had prototype capability, but no volume production. In May 1940, Lord Beaverbrook, newly appointed Minister of Aircraft Production, convened emergency meetings to address the bearing crisis. Someone mentioned Hoffmann's experiments. Beaverbrook summoned Barlow to London. The contract was simple and impossible. Produce 100,000 aircraft-grade ball bearings monthly within 6 months. 10 times Hoffmann's experimental capacity. Failure meant Fighter Command would run out of serviceable aircraft by December. Barlow accepted. He had no choice, and Britain had no alternatives. Hoffmann's factory transformed overnight. Gauge manufacturing space converted to bearing production. The company installed 20 grinding machines purchased from bankrupted manufacturers. Heat treatment furnaces were built in former storage areas. The workforce expanded to 600, mostly women, since skilled machinists were in military service, Training took weeks. Bearing production required 15 precision operations per bearing. Tolerances measured in microns. One flaw meant catastrophic failure. The first production bearings emerged in August 1940, exactly as the Battle of Britain intensified. Quality was marginal. Rejection rates hit 40%. But the bearings that passed inspection worked. Hoffmann delivered 85,000 bearings in August, 96,000 in September, 120,000 in October. By December, monthly production reached 250,000 bearings. By January 1941, Hoffmann's rejection rate had dropped to 8%. Quality control became obsessive. Every bearing was inspected. Dimensional accuracy checked with micrometers. Surface finish examined under magnification. Sample bearings from each batch tested to destruction, spun at extreme speeds until they failed. Temperatures recorded, wear patterns analyzed. The data fed back into manufacturing processes, grinding parameters adjusted, heat treatment refined. In March 1941, Hoffmann opened a second bearing plant in Stonehouse, Gloucestershire. A third facility followed in Coventry, rebuilt after German bombing had destroyed the original factory in November 1940. By mid-1941, combined production reached 400,000 bearings monthly. By 1943, Hoffmann produced 6 million aircraft bearings annually, enough for every RAF fighter, bomber, and transport plane. The strategic impact was invisible but absolute. Spitfire production accelerated. Mark V variants with improved Merlin engines entered service. The long-range Mark IX appeared in 1942. Each variant demanded more bearings, higher precision, tighter tolerances. Hoffmann met every requirement. Lancaster bombers, each requiring over 200 bearings, rolled off production lines in quantities that would have been impossible without domestic bearing supply. Halifax bombers, Mosquito fighter bombers, transport aircraft, all depended on Hoffmann bearings. The numbers that mattered weren't combat statistics. They were maintenance logs. Bearing failure rates dropped from crisis levels in August 1940 to negligible by late 1941. Aircraft availability rates increased. Squadrons maintained higher percentages of operational fighters. Fewer aircraft sat grounded awaiting parts. Germany, meanwhile, struggled with bearing shortages throughout the war. In August 1943, American B-17S bombed Schweinfurt, losing 60 bombers in a single day, trying to destroy German bearing factories. The raids disrupted production temporarily, but didn't cripple German industry. Britain faced no equivalent vulnerability after December 1940. While Americans died bombing Schweinfurt, British factories quietly produced bearings in unlimited quantities. By June 1944, when Allied forces invaded Normandy, 150,000 aircraft sorties supported the invasion. Every plane used Hoffmann bearings. Not one bearing-related failure was recorded in critical operations supporting D-Day. September 15, 1940, the day historians call the climax of the Battle of Britain, Flight Lieutenant James Nicholson landed his Spitfire at Biggin Hill after shooting down a Messerschmitt over the Thames Estuary. Ground crew inspected every bearing in his aircraft. Every single one functioned perfectly. The supercharger bearing showed no excessive heat. The reduction gear bearings ran smooth. The coolant pump bearing had thousands of hours remaining. Nicholson never knew his survival depended on precision grinding in a factory 30 miles away. Churchill's speeches rallied Britain. Radar provided tactical warning. Spitfire pilots showed extraordinary courage. But courage doesn't overcome seized bearings. Manufacturing won the strategic war that heroism couldn't. While Churchill declared, "We shall never surrender," Hoffmann workers on night shifts ground bearing races to micron tolerances, making surrender impossible not through defiance, but through precision. Germany's Luftwaffe faced chronic bearing shortages throughout the war. Messerschmitt production sat incomplete awaiting bearings. By 1944, Half of German aircraft production couldn't be completed because bearings weren't available. German engineers redesigned equipment to use simpler sleeve bearings when ball bearings ran short, but sleeve bearings required constant maintenance and failed faster. The cumulative disadvantage compounded over millions of operating hours. The irony is profound. Heinrich Hoffmann was German, born in Bremen, trained in precision engineering in the German tradition of exactness and thoroughness. He immigrated to Britain in 1891, founded his company in 1898, the same year Henry Timken patented tapered roller bearings in America. Both men brought German engineering discipline to Allied nations. Both companies helped defeat Germany, not through dramatic sacrifice, but through patient manufacturing. Hoffmann died in 1932, never knowing whether his company would save Britain. He just wanted to build precision instruments. He succeeded beyond imagination. The German immigrant who founded a gauge company in Chelmsford helped save Britain from Germany through mathematics, metallurgy, and micron tolerance grinding. After the war, American and Soviet engineers examined Hoffmann bearings. Quality matched or exceeded Swedish SKF. The precision manufacturing techniques developed under crisis became standard practice. Modern jet engines, including Rolls-Royce Trent engines, used in Boeing 787 and Airbus A350 aircraft, use bearing technology descended directly from innovations forced by wartime necessity. The Battle of Britain was won by pilots flying Spitfires, powered by Merlin engines built by Rolls-Royce. But every Merlin depended on ball bearings ground to impossible precision by Hoffmann workers who never flew, never fought, never made headlines. They simply made the machines that kept fighters flying. That's how wars are actually won. Not by heroism you read about, but by precision you take for granted. Not by destroying enemy factories, but by building your own. Between 1940 and 1945, Britain produced 20,351 Spitfires. Hoffmann manufactured approximately 1.4 million bearings for Spitfire production alone. Bearing-related Spitfire failures after 1941 were statistically negligible. The invisible victory was complete. Britain didn't need Swedish neutrality in 1942. It had something better: